All right, this video covers 9.2 from the support lessons. All right, so question one was Q plus 3 over Q equals -4. So since I got more than two fractions on this, basically, because the Q is a fraction, if you put a 1 under it, and the -4 is a fraction. So anytime you got three parts like this of an equation with fractions, what you want to do is find the least common denominator of all three bottoms. So you got a 1, a Q, and a 1. The least common denominator would be the Q, and then the ones, 1 times Q is Q, so you don't have to actually put the ones, but you could put a 1Q there, okay? So what you do is you take the LCD and multiply all three of these fractions by Q. So you'll have Q times Q over 1 plus Q times 3 over Q equals Q times -4 over 1. So the first fraction, what you would do is the Q times Q is Q squared over 1, but I don't have to write the 1 on this part. And then it's going to be plus, right here, these Q's cancel, turning into a 1, and 1 times 3 is 3. But notice what we wanted to do was get rid of the fraction, and then we have done that. And then here we got Q times -4, that's a -4Q over 1, so I don't have to write that 1. So if you had a 1 on the bottom, you don't have to write it. Now, since you got this Q squared term, makes this a quadratic equation, and we're going to solve this by factoring. So first, where that -4Q is, we need to have a 0 there, so we're going to add a 4Q to both sides. And I'm sort of putting the Q in the middle because I'm going to write this in descending order. So the highest exponent goes first, Q squared. Then I would write the plus 4Q, and then the plus 3. All that would equal 0 since it canceled on that side. So what you really got to watch out for is that since none of these are like terms, just put them in order. Now what you got to do is factor this left side and set it equal to 0. So you got a Q in the front, so that's going to be a Q and a Q. Anytime the last sign's positive, both of these factors will have the same sign as the middle number. So since the middle number is positive, both of these will be positive. So watch this. If this is positive and the middle was negative, I would have made both of these negative. If the last one's negative, I would have put a plus and a minus down here because they would have had unlike signs. And then the middle sign would have went to the larger factor had that been the case. So now, what's the factors of 3? Well, 1 times 3 is the only way to multiply and get a 3. And guess what? 3 and 1 add to get 4. So we're going to put both of them numbers. So we needed last factors of this last number that added to get the middle number, which were 3 and 1. Now, take both of these and set them equal to 0. And you're going to solve these by subtracting 3 on the first equation. So I get Q equals a -3. And then subtract 1 on the second equation from each side and get Q equals -1. So in the math lab, we don't have Q equals. All you do is put -3, comma, -1. All right, y'all. Number 2 is fractions, but it's a different style. I got 2 over x plus 4 equals 1 over x minus 5. So to do this problem, I'm going to use this property that says if A divided by B equals C divided by D, then A times D equals B times C. So what they did, they cross multiplied. A times D gives you one side, and then that bottom and the other top gives you the other side. So I'm going to do that to this. Just remember, these things that have two parts, both of these have to be multiplied by those other numbers. So first, I'm going to take the 2 and multiply by everything down there. So that's going to be 2 times x minus 5. That's going to equal the other side, which is a 1 times x plus 4. Now distribute. So 2 times x is 2x minus 2 times 5 is 10. That's going to equal 1 times x is x plus 1 times 4 is 4. Now solve this for the x. Now this one don't have any x squared terms, so I don't have to get everything on one side equal to 0 like I did this one that had the q squareds. Since I just got x's, I'm going to get the x's on the left side, numbers on the right side, and be done. So I'm going to start by subtracting that x from both sides. So 2x minus 1x leaves me 1x minus 10 equals, those x's canceled, so all that's left is my 4. All right, now I'll get that x by itself, so add 10. So they're subtracting, we're going to add 10 so that x comes down, the 10's cancel, and then that's going to equal 4 plus 10, which is 14. Final answer. Okay, so let me turn this page. And then all those equations that I'm doing, if you want to check them, just put those answers back in for those variables and see if you get a true answer on that, okay? All right, number 3 is the same as that one. Y plus 6 over y equals 6 over 5. Now, right off the bat, no, you cannot cancel those y's out. That wouldn't have been a good problem to give you, right? But this is a fraction equal fraction, so we can cross multiply. So y plus 6 is going to multiply by the 5. So that's 5 times y plus 6. So if it's got 2 parts, I always like to put that in parentheses. And then the other side is 6 times y. All right, so let's see. We distribute here. 5 times y is 5y plus 5 times 6 is 30. That's going to equal 6 times y, which is 6y. Now this one, we could be done with one move if we keep the variables on the right side, because you got 6 y's over there. This one has a y and a number. So let's subtract the 5y from both sides. So the y's cancel, bring down to 30. That's going to equal 6 minus 5 leaves me 1y. So if you put a 30 in, 30 plus 6 is 36 divided by 30. Well, y'all guess what? 36 divided by 30 reduces to a 6 over 5. So that would be, yes, a true statement. All right, so number 4 has a square root 4x plus 7 equals 1. So what you do to these, it's another property. If a square root of a equals some number b, then a equals b to the n. So what they do, they say to get rid of the radical, you raise the other side to the exponent that matches that index of the radical. Now, if you got a radical like this that don't have a number there, it's automatically understood to be a 2. So when you got radical equations, you want to get the radical by itself first, and then once the radical is by itself, you want to get rid of the radical by raising each side to the exponent that matches that radical. Now, since this 4x plus 7 is under the radical, it's technically by itself. So I'm going to go straight into what I got to do to get rid of that radical, and that's to square both sides. So when you square a radical, it's going to go away, and you're going to be left with what was under the radical, which is a 4x plus 7. Now, the right side, you don't have a radical, so you do got to square that. So 1 times 1 is 1. So it took one move to get rid of the radical. Now solve that for the x. So first I would subtract 7. And I get 4x equals a negative 6. And then divide both sides by 4. So when I cancel that, I get x equals a negative 6 over 4. But this will reduce to a negative 3 halves. Okay, so remember, Now remember, on the calculator, you can take that -6 divided by 4. It's going to give you a decimal answer. If you hit math and enter twice, it'll turn it into a -3/2. All right, 5 has a square root of 5x plus 10 equals 17. So this one, since the 10 is not under the radical, we got to get it moved to the other side where the numbers go. So we would start off by subtracting the 10 from both sides. So I get square root of 5x is going to equal 17 minus 10 is 7. Now, the radical is by itself, so we're going to square both sides, because remember, that don't have a number there, so it's automatically a 2. So you squared the radical is gone, and you're left with the 5x. And then over here, you don't have a radical, so you got to do 7 times 7, which is 49. All right, y'all, last step, divide both sides by 5. So I get x equals, all right, 49 divided by 5. If you try to reduce it in the calculator, it's going to give you a decimal. Hit math, enter twice. Notice it gave me 49 over 5, which means that answer will not reduce. So let me how you would check that. So to check that, because that's a fraction and it looks sort of funny, so let's take this. We got 5. In place of the x, we're going to put 49 over 5. And then plus 10 has to equal 17. All right, so first, under that radical, those 5s cancel, so you're left with 1 times 49, which is a square root of 49, plus 10 equals 17. So notice, you got to do all the work inside the radical first, then bring that radical down and take the square root of 49, which is 7. So now I got 7 plus 10 equals 17. Well, 7 plus 10 is 17. That equals 17. So that was true, which means that answer checked out. So if you want to check those, that's all you do is just plug those answers in and see what you get. All right, so number 6, we actually did a cube root of an x equals -9. So this goes back to the radicals. Since there is a 3 here, that means I need to raise both sides to the 3rd power. And put that negative in parentheses. So do parentheses, -9, close parentheses, and then use the caret to put in your exponent of 3. So this radical and exponent cancel, leaving the x. And let's see what we get on that. We get a -729. So y'all watch this. To check that, I'm going to put that -729 into that radical. So to get a cube root, you hit math and go down to number 4, which is a cube root. Hit enter. Put in -729, and I better get a -9. Okay, so here's what I did to check that. Okay. All right, let's see. This was the last one I had on that. And this is another cube root. So a cube root of x plus 8 equals 3. All right, so the x plus 8 is all under the radical. So the radical is technically by itself. So we're going to cube both sides to get rid of this radical, which means I'm going to cube my 3. All right, so the exponent cancels the radical, leaving me an x plus 8. And then over here, 3 times 3 is 9. 9 times 3 is 27. So remember, exponents just tell me how many times to multiply something times itself. All right, now to solve this, I would subtract 8. So that x equals 27 minus 8 is 19. So to check it, you would put the 19 in here. 19 plus 8 is 27. Cube root of 27 is 3. that is true, so that works out. All right, y'all, so I'm gonna stop this video, and that concludes my support 9.2.